Are you struggling with honeycombing, shrinkage cracks at site, and even structure failure due to low compressive strength? Oh, not this problem again. I have executed this more times than I count. And see, what I have found in my root cause analysis is 90% of the time the real problem is concrete workability at the time of pouring. So today let's understand the concrete workability, especially at the time of pouring. So hello everyone, welcome back to the channel. In the continuation of our concrete mix design series, already we have understood what is grade of concrete, type and grade of cement, maximum nominal size of aggregate, minimum and maximum cement content, how to choose the right water cement ratio, and how to choose exposure condition. So today we are going to learn what is concrete workability, why workability at the time of pouring is so critical, correct slump values, and common site mistakes to avoid. In the end of this video, we will see some interview question and answers. So learn each and every point till the end. So let's start with what is workability. Concrete workability means how easily fresh concrete can be mixed, transported, placed, compacted, and finished without segregation or bleeding. In simple words, concrete should flow easily into formwork and around reinforcements, but it should not become watery or separate. Now we jump to the second point, which is why workability at the time of pouring is so important. At the time of pouring, if workability is not proper, defects start immediately. If workability is too low, concrete becomes stiff, difficult to place, honeycombing occurs, poor compaction around reinforcement. If workability is too high, segregation happens, excess bleeding, strength reduces, and durability decreases. So the next point is what is recommended slump at pouring time. For the required workability, we will simply follow the IS 456. So let's jump to directly on IS 456 clause number 7.1. So you can see the requirement of workabilities for different type of structures and placing conditions. The first point mentioned here, the blinding concrete, shallow sections, pavement with pavers. For these concrete, the degree of workability is very low. It is referring to 7.1.1. So let's clear this point first. See, in the very low category of workability, where strict control is necessary, for example, pavement, quality concrete, measurement of workability by determination of compacting factor, will be more appropriate than slump. He is saying that for very low workability category, we should test compacting factor, not the slump test. And what will be the value of compacting factor is 0.75 to 0.8. Okay, so let's come to the chart. If we come to the next placing condition, which is mass concrete lightly reinforced section in slabs, beams, walls, columns, floors. In these structures, we need low workability, which is going to be tested by slump cone, and the value will be 25 to 75 mm. And you can check the next degree of workability and slump for their respective placing conditions. But the third option, heavily reinforced section in slabs, beams, walls, columns, slip formwork and pumped concrete, is being used in everywhere 90% of the time, and the degree of workability is medium, and the slump is 50 to 100 and 75 to 100, which is very low for a pumpable concrete. It is very common that we are using super plasticizer in our concrete mix to reduce water and increase the slump. So why IS 456 mentioned very low slump for the reinforced concrete and pumped concrete? To clear this confusion, we will see the note below this table. For most of the placing conditions, internal vibrators are suitable. The diameter of the needle shall be determined based on the density and spacing of reinforcement bars and thickness of sections. For semi-concrete, vibrators are not required to be used. So maybe the question blinks in your mind, why low slump concrete still works with the vibration? The myth fixed in our mind is slump equal to workability. That is not true. Slump only measures flow under self-weight, and workability means ease of placing, compacting and finishing. Low slump concrete looks stiff, but it can still be highly workable if vibration is used. What vibration actually does? When you apply vibration in low slump concrete, internal frictions between particles reduces, aggregate rearranges into a deeper packing, entrapped air escapes, and concrete temporarily behaves like a fluid. Engineers call this temporary liquefaction. So even a 25 mm to 50 mm slump mix flows around reinforcements, fill corners of formwork, achieves full compaction. Because vibration provides the energy what slump doesn't. That's why low slump plus vibration equal to perfectly dense concrete. Now let me tell you the benefits of low slump concrete with vibration. Lower water cement ratio, which clearly means higher strength. We have already discussed this point in our water cement ratio. Less bleeding and segregation, better durability and less shrinkage cracks. That's why mass concrete, pavements and foundations often use low slumps plus vibration. So now we know the benefits of low slump plus vibration. But where we cannot use the low slump concrete, that's the most important thing you should know. So let me tell you that we should not use the low slump concrete where the vibration is insufficient. And the second, where reinforcement is very dense, we should not use the low slump concrete. And the most important point is where we require pumpable concrete, we should not use low slump concrete. In these cases, higher slump or self-compacted concrete is required. So the next point is how to check the workability of concrete. The first is slump test, which is very common at site. And the second is compaction factor test, which is especially for low workability. And the third is flow table test, which is for higher workability. So boom, we have learned workability of concrete. We have come to the end of this video. So we will see some interview question and answers. The question is how low slump concrete works with vibration. Because the vibration temporarily reduces the friction between particles, which is allowing concrete to flow, expel air and fully compact despite low slump. So our next video topic is transportation time, method of placing and degree of site control. So if you are eager to see, just subscribe the channel, otherwise you are going to miss those videos. If you found this video useful, so please like and share with your site colleagues.